Hello students, in this the lab practical on the SMAW, that's the shielded metal arc welding or also known as manual metal arc welding process. We'll try to learn the different aspects. So the main objective of this practical is to demonstrate the procedure of arc welding, to impart the information on the various system components, and to demonstrate the role of the polarity in SMAW, and also to communicate the fundamentals, working principles, applications, advantages, and the limitations of the shielded metal arc welding.
Hello students, in this practical demonstration we will be talking about the shielded metal arc welding process, and later on we will see the demonstration of this process. You know, this process is based on the very simple principle of using the heat being generated by the electric arc, and that arc heat is used for, like say, melting the edges of the plates. Like these are the two steel plates, so these are to be fused. These are to be fused in order to have the metallic continuity along the weld line. So to develop the arc, so the most important thing here is to develop the arc so that heat can be generated in a very controlled way in order to realize the true thickness penetration during the welding. So how the arc is generated, like say there is a power source. For shielded metal arc welding, mostly we use the transformers for AC, and the rectifiers and the generators for the DC welding. Each one will have its own capacity. This particular transformer has got a rating, say, from 25 to 300 ampere. So depending upon the thickness of the sheet, we set the welding process for the different current values, so that the same will be supplied through the arc to the workpiece for closing the circuit, so that arc can be established. So here you can see there is a transformer and there are different control panels, and here there is a cable through which the power is being fed. This is the electrode holder, which is very easy to hold and unhold the electrode at a particular angle. Okay, since it uses the replaceable electrodes, electrodes will have the limited length of, say, 300 or 400 mm. So these are consumed in process of the shielded metal arc welding. And here you see, if this electrode, so this is the electrode holder is connected with the cable to feed the power supply, and here you see this is the electrode. Inside there is a core wire. This is mostly made of the metal composition as per the base metal which is to be welded, or any other composition for the special requirements. So this is diameter of this the wire which is further covered with the coating or the flux. So we call it diameter of this wire is termed, this is called core wire, and its diameter indicates the electrode size. It may be 3.15 or at 4 or 5 as per the heat to be generated to weld the plates of the different thicknesses. So thickness of the plate primarily dictates the electrode to be used, and that in turn dictates the kind of the current to be used for the welding purpose. And you know that this is the coating of the flux which plays a number of roles. For the first and foremost is like the easy arc initiation. Then this the flux decomposes during the welding and provides the effective shielding to the molten metal, so that the sound weld is developed, which is free from the inclusions and the defects. So here, so during the welding, very intense heat is generated, and that generates a lot of harmful radiations are all generated during the arc welding. So it is very important to protect the eyes. So for protecting the eyes, a face shield of this kind can be used, or goggles are also there for the protection purpose, so that you can easily handle the arc as well as you can control the the arc and the weld pool as per the need. Apart from these two things, there is also, you can say, the hammer. This is called chipping hammer, which is used to remove the like the slag which has been developed after the welding over the plates. So you can see the number of electrodes are there because these are consumed in process. So indirectly say this is also consumable type of the arc welding, where electrode itself is consumed. Electrode plays the two roles here. It helps in establishing the welding arc, one. At the same time, the melting of the electrode facilitates the feeding of the molten metal to the weld pool for the development of the weld joint. So this is one of the most common welding process in most of the repair shop and workshop. This kind of the welding is performed because of the two reasons. One, it is very easy to do, easy to control over the molten metal, and the kind of the power transformers which are used, they are also very cost effective. So nowadays you can see they are very light in weight, maybe 10 kg, 15 kg, so you can easily transport from one place to another. Certainly you need the domestic power supply for the purpose of establishing the welding arc, so that you can provide the required power during the welding. So in SMAW process, you know that the arc has to be established, and the arc is established whenever the circuit is completed. So the one terminal of the transformer is connected to the electrode, and the another one is connected to the work table on which the plate to be joined. So the terminal which is connected to the work table is known as the ground connection, and position of that ground connection we can choose as per the requirement to avoid the arc blow kind of thing, or it can be placed at any other convenient position. So basically the one terminal is connected to the electrode holder and another one is connected to the work table, so that the circuit is completed when arc welding is performed. So shielded metal arc welding is one type of the fusion welding process, where the sufficient heat should be generated in order to fuse the plates or the sections to be joined, and the heat generated depends upon primarily on the welding current being supplied. So depending upon the thickness of the sheet to be joined, you can see for 1.6 mm, for 3 mm, for 6 mm, and for 9 mm and 12 mm or above. Like say the plates of the different thicknesses are to be joined, then we need to use the different current values, because thicker the plate, greater the heat required, and that can be generated through the simple formulation of like VI, welding current, and the voltage. So the voltage is by and large fixed, maybe 30, 40 or 50 depending upon the kind of electrode, but the current is adjusted as per the need of the heat to be generated for welding of joining or welding of the given thick plate. And for as per the thickness of the plate, we need to select the suitable current, and as per the current setting that we need, we choose the suitable electrode size. So if you can see 1.6 mm, 2.5 on the different electrodes for the different current rating. If you see, this comes out to be around 35 to 40 times of the electrode diameter. Okay, so this is indicating electrode diameter, which is primarily the core wire of the electrode, not the diameter of the electrode with the flux. Okay, this is another way of representing the electrode of the different sizes. So now we will show you the demonstration of the shielded metal arc welding process and how do we do it procedurally. Okay. So for developing the shielded metal arc weld joint, first of all we have to strike the arc. So arc, to strike the arc, electrode is touched at elsewhere, so that there is a completion of circuit and arc is established. Then arc is moved towards the plates which are to be joined. So to maintain that the plates to be joined are kept in particular position and spacing, we do the tack welding. So the tack welding is being done. So this will help to retain the two plates to be joined in a particular position so that they don't go out of position. So this is like so this is how do we move the arc towards the location where heat is to be applied. So here in very controlled way the arc is being moved along the weld line so that there is a proper deposition of the molten metal as well as the through thickness penetration is also realized. The process is quite fast, but it requires a lot of skill in order to manipulate the arc, control speed and the movement of the arc, and avoid the sticking of the electrode with the workpiece. So the welding current and the speed of the movement of arc determines the amount of heat being supplied during the welding. So this is how you can see the weld is done, and here we have replaced the electrode, and again the welding will be continued where from it was left. Okay, so this is one of the drawbacks also of the shielded metal arc welding, where we use the electrode of a particular length. Once it is consumed, we have to stop the process, and again the electrode, a new electrode is used. So this brings in the little discontinuity or breakage in the welding. So we may find that that location where from the next electrode has been used for the welding purpose, that may be full of the discontinuities also. So now we can see that whatever the slag has been deposited, that we can take off using the chipping hammer. Okay, this is very important. It says especially it is important in case of the multi-pass welding, because if it is not removed, then it can be retained there as an inclusion. Okay, so this is how we can see the shielded metal arc weld joint can be developed using the arc welding.
Arc welding is also referred to as stick welding or manual metal arc welding, in short MMAW, in which an arc is struck between the flux-coated consumable electrode and the base metal to start the welding process. It is the most common type of welding process seen in any job shop industry. Working principle. In this process, the heat required to melt the consumable electrode and form a bond with the base metal is produced by an electric arc struck between the electrode and the workpiece. The shielding for the weld pool is provided by the flux, some of which is deposited on the layer of the weld in the form of slag, which is removed upon cooling. The choice of electrode depends upon the base metal composition. If you are new to ADTW Learn, click on the subscribe button and turn on all notifications so that you never miss an update. Equipment or components of shielded metal arc welding. Power supply. Transformer. Most commonly, welding transformer, a DC rectifier, or a DC generator is used. Electrode holder. Electrode. Ground clamps. Working. First, the power adjustments are made on the transformer. The welding can be carried out by either using direct current electrode positive, DCEP, or direct current electrode negative, DCEN, connection. DCEN. In DCEN, the electrode is connected to the negative terminal and the workpiece is connected to the positive terminal. The electrons thus travel from the negative terminal to the positive terminal. That is, from the electrode to the workpiece. Since there is a sufficient potential difference between the electrode and the workpiece, therefore the electrons from the electrode accelerate and strike the workpiece surface at a very high velocity. Upon striking, the kinetic energy of the electrons is converted into heat or thermal energy, thus an immense amount of heat is generated at the workpiece surface. About 66% of the arc heat is generated on the surface of the workpiece, and the rest of the heat is generated at the electrode surface. This melts the base metal quickly, thus resulting in deeper penetration. However, the deposition rate of the filler metal reduces due to less heat generation at the electrode surface. DCEP. In this polarity configuration, the electrode is connected to the positive terminal and the workpiece is connected to the negative terminal. And hence the flow of electrons is from the workpiece to the electrode. A major amount of arc heat is generated at the surface of the electrode and less heat is generated at the workpiece surface, thus resulting in a higher filler deposition rate and insufficient fusion between the workpiece and filler metal. However, when the electrons flow from the workpiece, the dirt and oxide layer is disrupted, also known as arc leaning action, thus helping in producing a quality weld bead. After setting the necessary current and voltage parameter, an arc is struck by slightly touching the workpiece with the electrode and carrying forward or backward. Once the arc is struck, the heat generated melts the electrode and base metal, and the filler metal gets deposited on the base metal. The electrode should be held at a lower angle to the workpiece to initiate an arc and to carry on the welding process, but if the electrode is held perpendicular to the workpiece, then it is likely that the tip of the electrode may stick to the workpiece and fuse, causing it to heat up rapidly. The flux then converted into a shielding gas surrounding the weld pool, protecting it from oxygen and other atmospheric contaminations. Some of the flux gets settled on the weld puddle in the form of the slag. Once the welding is completed and the weld bead is cooled down, the slag is chipped off using the chipping hammer and cleaned using a wire brush. Shielded metal arc welding can be used to weld in all positions. That is, flat, horizontal, vertical, and overhead. Advantages. The initial cost is low. The welding equipment is simple and portable. Flexibility of the process in using a wide variety of electrodes. The electrode is flux-coated, which provides shielding, hence no need for heavy gas cylinders of shielding gases. An efficient and low-cost way of joining metals. And good for welding in tight spaces. Disadvantages. A highly skilled person is required to produce a good quality weld. Defects are hard to detect in the weld. The process is manual and hence high labor cost. Fumes and gases produced by the flux are hazardous. Application. This process finds its application in structural welding, job shop, shipbuilding, field repair, marine, aerospace, and nuclear. Hope you have understood.
So some of the questions for self-assessment includes like what is the meaning of the ground connection in SMAW and what is its role, especially with regard to the arc flow, and what should be considered while selecting the polarity for SMAW. So what are the different points that we should keep in mind? Then what are the typical applications of SMAW, and how does the SMAW provide the protection to the weld pool from the atmospheric gases? If there is no proper protection, then various types of the weld defects are